I will be presenting Algorand, an institutional-grade, developer-friendly, utility-driven blockchain. My name is Sara Kenny. Was a developer champion for the Algorand Foundation, but I recently joined officially, and I'm now the junior developer community advocate. So I'm really excited to get this started. A little bit about me: I've been working in the industry for 3 to 4 years across startups with community and social media management. But then I turned a bit more technical, and I'm currently studying software development in university over in Ireland. So feel free to connect with me on LinkedIn. Just search my name, Sara Kenny. And also come join the community on X. You can follow Algorand Foundation at Algo Foundation. But let's get in store. What will we be doing today? So firstly, we'll do an intro to blockchain and Algorand technology, as well as a live interactive coding building session using the Algorand Python SDK. We'll also be showcasing a Python smart contract on Algorand, as well as how to set up your developer environment and where to find the best resources. And then obviously after that, where to continue your journey, and hopefully you can start building your dream ideas. And just for anyone who did go to our past workshop, I do have some new content in here, especially during the live coding segment and the showcase of the Python smart contract. So yeah, let's get straight into it. And also, if anyone has any questions, I could take them more at the end, but I'll make sure to try keep an eye on the chat. But let's get straight into it. What does blockchain solve? So some of the examples and the main ones I'd say that everyone's probably hearing at the conferences all the time is decentralization, transparency, and immutability. So for decentralization, blockchain eliminates the need for a central authority, which reduces the risk of centralized control and failures, basically cutting out the middleman. Transparency, so like Algorand, as well as many other blockchains, they're a distributed ledger. And with a public ledger like that, you can see all the transactions, and this ensures accountability. As well as immutability, once recorded, transactions cannot be altered, ensuring a permanent and reliable record. What is Algorand? What makes it different? So let's get back to the roots, the origins. The founder, Silvio Micali, is an Italian computer scientist and MIT professor. He's also known as one of the modern forefathers of cryptography, thanks to his work such as co-inventing probabilistic encryption, zero-knowledge proofs, verifiably random functions, and of course, Algorand, which was founded in 2017, and the first Genesis, which is basically the first block or the first transactions that ever happened, was in June 2019. And if there's anyone particularly interested in cryptography and blockchain security here, in a more short sentence of what he has co-invented, and I know zero-knowledge proofs have been more in the news lately. So what a zero-knowledge proof is, basically it allows verification of knowledge without revealing the actual information. And I'll leave that with you to think about. But yeah, in a sentence, Algorand is an enterprise-grade programmable layer 1 blockchain with instant finality and low fees, enabling consistently high TPS, which is transactions per second, and minimal energy use. And this enables solutions at scale, projects at scale. Our technology, our tooling, our investments, everything we do is about enabling innovative real-world solutions at scale. And only at Algorand can we really talk about true scalability without any sacrifice to the performance. So let's get into the facts. So Algorand has a transaction per second of theoretical 10,000. No chain is consistently hitting 10K TPS at the moment. But one of our community developers was able to get around 9,000 transactions in a single block. And Algorand was stable and reliable as ever, which is great proof for projects who are needing the reliability, for example, like payment systems. We have a second block time less than 3 seconds, a 0.001 algo fee. So that basically is like a tenth of a US penny. We also have instant finality, which is unique about Algorand and its need for consumer adoption. So I'll talk a little bit more about instant finality in a later slide. Algorand mathematically cannot fork. When a blockchain fork, it basically means it splits into two competing paths. And obviously, you need to have one solid, reliable blockchain so it can keep authenticity. I remember in the last workshop, I gave the example there can be no two Mona Lisas. So to change it up a little bit, I'll talk about Michelangelo. There can't be two statue of Davids. We also have no rollbacks on Algorand, which is basically when a series of confirmed transactions get reversed. And that's really not very decentralized. We also have zero downtime since its inception, which adds more to the proof of reliability of Algorand. And as of January 2024, we need to get a new update on these. I'm sure it has gone up as well, but it has been recorded. Algorand has produced 35 million blocks, a huge 1.4 billion transactions, and 600,000 active users on chain. Let's get into the art of the tech. Let's take a look inside the core technology of Algorand itself. So this means the consensus mechanism. But what is a consensus mechanism? The most important and fundamental task in a blockchain is the secure, reliable, and fast creation of the next block in the chain. The tool to create and validate the next block in a blockchain is called the consensus mechanism. Every blockchain uses a consensus mechanism. Early blockchain, uses a consensus mechanism called proof of work. Bit of a tongue twister. And proof of work is used by like Bitcoin. And while this was useful at the time to prove out the concept of blockchain, it has been shown to be very slow, expensive, and energy inefficient way to write the next block in the chain. Algorand, which founded in 2019, first Genesis block in 2019, uses a innovative consensus mechanism called pure proof of stake to write the next block in the Algorand chain. So consensus requires 3 steps to propose, confirm, and write the block to the blockchain. These include the propose phase. One account is chosen to propose the block. The second one is the soft vote phase. A committee is chosen to soft vote on the proposal. And third, the certify phase. The new committee chosen to vote on certifying the block. Each block has a new proposer and new committees chosen at random using the power of VRF. This leads to player replaceability, a powerful tool that enhances the security. Anybody who has a token can participate, so there's no static target to attack. There's also no heavy computation with VRF, as it is considered a simple task, and all of this is done in a process that takes less than 3 seconds. This is how Algorand essentially solved the blockchain trilemma, creating a blockchain that has global scale, robust security, and true decentralization at the consensus mechanism level. So everything you need in a layer 1. So these are some cool things that are features of Algorand. So we have Algorand smart contracts. Algorand makes it easy to tokenize, transfer, and program conditions of any instrument of value. You can create fungible and non-fungible tokens with a single transaction where no smart contract code is required, or program more sophisticated decentralized applications with Algorand smart contracts. And you can do this all in Python now. But you can also write in 4 SDKs, Python, JavaScript, Golang, and Java to connect to on-chain assets or applications. We also have Algorand Standard Assets, which is basically just a token on the chain, and we'll be creating one of those later. ASAs are known for the efficiency, scalability, and security. Basically everything that Algorand gives as a blockchain, ASAs inherit. We also have a really cool feature, atomic transfers. Algorand's atomic transfer feature allows multiple transactions to be grouped together and executed atomically, ensuring that either all transactions succeed or none of them do. And this is key for truly trustless transactions. And we also are going to do that later in our live coding. So I'm really excited to showcase that. It's very easy with Algorand. We also have on-chain randomness. Having a source of trusted and secure randomness is necessary for decentralized applications that depend on randomized processes. So you could think of some of those like lotteries, or maybe more Web3 like a random NFT drop. And we also have Algorand state proofs. So we are hearing more about quantum every single day. And I think it's a part of technology that we have to embrace, because we could do amazing things with quantum computers. But of course, we don't want to fear it at the same time. Algorand's really at the forefront of this. State proofs are basically a cryptographic proof of the account status. So that means a snapshot of the accounts happen at a specific time, and that's every 256 blocks. So in around 12 minutes, if you do the maths of 2.8 average per seconds per transaction, in about 12 minutes, the entire chain's history is quantum secure. I won't get too technical into it, but we are 1/3 of the way of being a fully quantum secure blockchain, and we're leading this innovation in the blockchain space. Further research and development is underway for quantum secure VRF and transaction signature scheme. Those are the two last pieces we need to be a fully quantum resistant and proof blockchain. So the Algorand virtual machine versus the Ethereum virtual machine. So while TPS and throughput measures how many transactions the blockchain can process per second, time to finality measures the time it takes for a transaction to become irreversible once it's confirmed and added to the blockchain. And that's where I was mentioning instant finality earlier on. With Algorand, it's instant. So that's quite a jump into the modern day blockchain like Algorand. If we have a look at some other comparabilities, the programmability of ETH, it has Solidity, which is working out really well, but it is also a new language to learn to build on chain. There's also Viper. Sometimes we get questions like, is Viper not the same? Viper is not a native Python, but a distinct programming language inspired by Python for writing Ethereum smart contracts, whereas Algorand uses native Python, which allows developers to write and execute smart contracts directly in Python. So, built for the builders, it's all about developers, developers, and developers. For Algorand, we want to make the best developer experience for blockchain. Soon, we'll be going to our GitHub code space. The only thing you need for this tutorial is your GitHub account. So if you don't have one, quickly make one. And I'll share the links of where we'll be going to and getting ready for that. But just a heads up if you want to get your GitHub ready. Down the line with AlgoKit, there will be plug-and-play library of smart contracts and improved debugging and integration of an additional common programming language. AlgoKit changes the blockchain developer's game from the command line, compiler, top-class libraries, easy-to-call smart contracts with client generator, instant access to testnet tokens, and of course, what does every developer Web 2 or Web 3 need? A solid debugger. As you know, Python is used to code machine learning and artificial intelligence, and thanks to Algorand, now smart contracts, it opens up the gate to tens of millions of Python developers. And also you learn Python whether you're in high school or you're in your first year of uni, and etc. It's the open gate to programming. Before we jump into coding together, I thought it would be a good idea to show you guys the challenge that you will have to complete to get your points, your Builder points. And a reminder, this one is worth 24 points, which is equal to like 24 USDC. So it's definitely worth it. And I promise it will be easy to do once you follow this tutorial. So just to outline the challenge needed to complete the Algorand workshop, before we hop into code, it might be nice just so you can see it. So what you need to do is create 2 Algorand accounts, create an Algorand Standard Asset, transfer the created asset to the opposite account, and claw back any amount of the created asset. The proof of completion can be, I know you will also be sharing your GitHub anyway, but for any proof of completion, you can do the terminal or the specific part of the clawback, which is a new thing that I'll be showing you, which was not present in the last tutorial. The clawback address basically represents an account that is allowed to transfer assets from and to any asset holder, assuming that they have opted in. You can use this if you need to have the option to revoke assets from an account, like if they breach any certain contractual obligations tied to holding the asset. But now let's take a look at Python on Algorand, the first blockchain to successfully use native Python for blockchain development. So let me share my new screen. Perfect. Hopefully you guys can see my GitHub here. So I will share the link in the chat right now of where to go. Perfect. So in the chat, I've just sent a link. It's the GitHub to where we'll be doing our code space. And I'll wait for people to get on there. What we'll be doing here is, for those who are already on it, something that might be handy for you is if you fork, and it's very easy to fork, you just click fork and confirm the fork, and it'll take you to the exact same repo, except it'll be on your account. So that might be handy for you if you want to save your code, and you can export it from your code space, which I'll show how to do later, as I know there could be some beginners here who may only be opening up GitHub for the first time. So yeah, the link is in the chat. I'm going to continue on for the recording. So if we go here and we click create code space on main, you can get there by clicking the big green code button. And I'm going to click it because it will take, I will share this screen now. It will take you to a new screen, and it will take just a few minutes to set up. In the meantime, I'll have a look at chat, see if there is any questions or any troubles. Seems all good. So now we're just going to let this load in. What's essentially is happening is when we click code space, it's creating a virtual environment, and it creates everything for you. So of course, when you're programming in Python, it compiles with the interpreter and whatnot. But when you're communicating with a blockchain, you obviously have to communicate with the blockchain. So this is doing all of that. I'll show later what you need to get your local environment set up, but this is just a great way to practice and have everything all in the one space. So you just need to give it a minute to let it load everything in. And then I have one command that we have to run in our terminal to make sure we get the latest dev tooling for this workshop, which is really cool that we get to experience the latest tooling, which will be coming out officially in the future. So this is still in beta. Awesome. So we are just getting the our space all set up. And also just wanted to mention, I did include a README because I thought it'd be handy for anyone who is looking back and say you're like, oh, what was that command that we're about to run in the terminal again? Instead of trying to find it in the video, you can also find it in here. I have the all-in-one Algorand code space, how to start a code space, how do I enter an old code space, how to use the all-in-one Algorand code space. So if we see here, once your code space is fully loaded in, run the command sh algorand underscore setup.sh. So if you guys are following along, please feel free to type that in the terminal, and we're going to press enter, and now it's going to run up the script so we can use the latest dev tooling, and also we can experience AlgoKit later on in the virtual environment. Bitpod.io is similar to CodeSpace, as someone said in the chat. I'm not too sure, so I won't speak on it, but if it is a virtual environment that it gives you, That's pretty similar. But yeah, so we have just run our command in there. If you guys are continuing along, please feel free to do so. Finally, at the end of the README, there is enjoying the blockchain developer experience, which hopefully you will. And this is what's needed for AlgoKit for your local, but we can talk about that later. And finally, you can join Algo Dev's community and work with thousands of developers just like you. We have a Discord, which our DevRel team are active in, and our Algo Dev's Twitter. But now let's actually get into the coding. So if you can see on the left-hand side, we have our main.py, our Python file. If you get the pop-up like I just did on the bottom right-hand side, you can click install if you like. We're going to use it a little bit later on. So while it's popped up, I'm just going to have it installed there now, but we don't necessarily need it for this first part. So to get started, what we'll be doing is very similar to the challenge. We'll be creating 2 accounts, funding them, opting into the asset that we create, and sending that asset, and then I will show a little bit of clawback so you are not totally stuck for the challenge. So what we need to do straight away is import the modules that we'll be using to interact with the Algorand blockchain. So if we do from algokit _ utils .beta .algorand _ client space import and open up your parentheses. Once these AlgoKit utils is out, and all you'll need to do then is just take away the beta when it's fully out. But for the moment, we're going to keep it in. So we're going to import the Algorand client. And don't forget the commas. It's a very simple mistake to do. So if something's not working, it's probably a syntax error. We're also going to import our asset create parameters, params, as well as our asset opt-in params. We're then going to do our asset transfer params, as well as our pay params. And finally, well, we actually won't need to add asset freeze params, so I'm going to leave it here. This is all we need to import to get started and start interacting with the chain. So hopefully everyone's following along, but it's totally cool if you want to do it afterwards when the video is recorded as well. So now we're going to create our client and have it connect to the local net so we can open up that communication to the blockchain. So we're going to have Algorand equal to Algorand client, what we just imported above, and we're going to have default local net with open parameters. After this, we're going to import our dispenser from the KMD, which is a key management daemon. The dispenser is just a way to get your testnet tokens or your testnet tokens, essentially, but you can do it on local or you can do it virtually like we're just about to do. So if we just create the dispenser equal to algorand.account, because the dispenser is an Algorand account, and have it .dispenser with open parentheses again. And I always like to start seeing something straight away in the terminal. So let's do a print statement. Let's do our dispenser address. And to get our dispenser address, we just simply write our name that we created as the dispenser, which is dispenser. And we do a dot, and we can see in here, we have 2 objects. We have the address and the signer. That's basically the address is your public key and your signer is your private key, which is used to sign transactions. But for now, we just want to see the address. And if we head in here, let me just clear that. And we do Python main.py, we can see our dispenser address in our terminal, which is pretty cool. So let's keep going. So next we're going to start creating a wallet. So we're going to create our first Algorand account together. I'm going to call this account creator as it's going to be the one creating the asset. So if we do creator is equal to algorand.account, and you're going to start to see a bit of repeated terms as we keep going, which is good. And we're going to do dot random. So we're just going to generate a random account. And let's also print this out. So if we do a print statement again, and by the way, you don't have to do the print statements every single one with me. This is just for the presentation and the explanation, but it's pretty cool to see. So feel free to test it out. And here we're going to print out our creator address. So we're going to do creator.address. Now, if we are to run this again, we should get two addresses. Perfect. We have our dispenser address, which stays the same as we're pulling from the exact same dispenser. Our creator address will change each time because it's a dot random every time we run it. We can also get our information from the address, which is interesting to see. So let's do print algorand.account.get_information. And inside these parentheses, we are going to do creator address. And if we run this again, we can see the creator address is the same for what it needs to be during the run of the script, but it's different from the above one because it's both random. But we can see inside here, we can see things like our amount, we can see total assets opted in, total created assets, and etc. So you get a whole overview of the account. I'm just seeing in the chat, someone's seen a syntax error. If you could just pop in your code into the chat, maybe I can have a quick look. But it's either maybe a comma missing or pretty much probably just a comma somewhere. But feel free to look at my screen. So now after this, we are going to do, we're going to fund our creator address, because to do things on the blockchain, you need to have a minimum balance requirement. So we're going to create our first transaction. This is going to be pretty fun. So we're going to do Algorand.send because we're sending to the blockchain. And it's going to be a payment. So it's dot payment. Inside here, we're going to use one of the modules we have above. It's going to be the pay params. And here we're going to open up the parentheses again. And in here, we're going to have our three main parameters. Our sender, which will be equal to the dispenser because this dispenser is going to be sending us the testnet algos. We also need a receiver who's going to receive these, and that's going to be our creator address. That's creator.address. Don't forget the commas, and then the amount. So how much are we sending from the dispenser to our receiver? So if we do our amount here, and we can do 10 million microalgos, which is equal to 10 algos. Perfect. I'm just going to move this actually over here, and hopefully this can make it bigger for you guys, maybe. Perfect. Now what we can do is we can check out the creator account after the changes of doing the funding. So let's quickly do that. I'm going to just copy this statement, this print statement from above, and I'm going to start to comment out some as it will start to clutter, I'd say. So now we are going to see what it is like before and then what it is like after our first ever transaction. So if we go into our terminal and run this again, we can see here, I'll clear the terminal next time, but here we have our same account address, and before the transaction we have 0, and after the transaction we have 10 million microalgos, which is 10 algos, which is plenty enough to do since the minimum fee on Algorand for a transaction is 0.001 algo. So now let's create our Algorand Standard Asset. We're going to create our first token. So if we go over here and we name our transaction, we'll just name it sent transaction. And we have this equal to Algorand.send. And instead of payment here, we're going to do asset create. because we're creating an asset. Inside this, we're going to use the params that we imported from above as the asset create params. We're going to open up these parentheses as well and fill in the parameters that we need to do. So firstly, we need a sender. The sender is it's the creator. So we made a good wallet name, but the sender is essentially the creator of the asset. The creator could be Bob, could be Alice, but for the moment, we named our creator wallet creator. So we will just add our creator dot address and a comma. Then we need the total. What's the total amount we are going to make of this token? So let's just do 1,000. Rarity is value. We're also going to make an asset name. And inside our quotes, this will be the name of our asset. So let's keep it on key and do build here. Then we'll also do our unit name, which is basically the abbreviation. And we'll do H3 or for her. In the last tutorial, this is what we would have done and we would have moved on, but I'm going to show you guys some cool things. So when you create an asset, you can have different addresses manage certain things. So for example, we can have a manager. And that address can change the other addresses, like the reserve or clawback. And we're going to set our manager address to the only address that we have, which is the creator address. We're also going to do our clawback, which this is important for the challenge later on. And we're going to set that address to the creator. We're also going to do our freeze address. And that's basically where it can freeze an asset in any account. So if you freeze an asset, it means that no accounts across the blockchain can send that asset anywhere and nothing can happen to it. This is used for regulation purposes. So the fact that it's an option, and on Algorand, you can turn it you can choose it to be true or false. Same with clawback. So they're all optional, but the fact that the option there means that there's a lot more agility with it. So we're going to set this to the exact same creator.address. Perfect. So now what we're going to do is after we create the asset, we want to extract the asset ID. So this is basically how we can identify the asset on the blockchain. So let's create a variable here. Let's call it asset ID. We're going to have that equal to our transaction above, which is called sent_transaction. Inside this, we're going to do our square brackets and our quote. We're going to have confirmation in here. Make sure my spellings are correct. And then we're going to do another box, and we're going to have our asset index. Perfect. And now we've done a lot of coding, so let's actually see some stuff in the terminal again. So let's print out the asset ID. So if we go and do a simple print statement, we can have asset ID and just attach our asset ID variable. So now if we run the code, and what I might do is take one of these print statements off. Yeah, I'm going to take them both off just so everything's clear in the terminal. So if I clear and I bring this up, we should see a four-digit asset ID. And perfect. So the build her token in our virtual environment is asset ID 1003. Perfect. So now let's actually start interacting with this token and other accounts. So let's create our next account. Some of you may have already remembered how to create an account, but what I'm going to do is I'm just going to pull it from above as it's the exact same code. And I'll show that print statement as well. So if I just copy that, and I'm going to take that one down just for the aesthetic. So now what we'll do, instead of calling it creator, we're going to call it receiver underscore account. You can call it anything you want. You could call it your name, or you could get super creative. We're going to print off our receiver account now. Oh, my spelling. That's the receiver. Yes, perfect. Be careful of the typos. That's an honest mistake in a programmer's life. So now I'm going to run this code, and what we should see is the creator address, our asset ID, and our receiver address, which is our second ever account we've created on Algorand. Perfect. So as you can see, they're both different because they're both different Algorand accounts. Now what we want to do is transfer the asset from the asset that we created, the build her token, from the creator wallet to the receiver wallet or receiver account. So to do this, we're going to create another transaction, an asset transfer. So if we have that equal to algorand.send.asset transfer, and we open up the parameters, and the module that we're going to use for this that we imported way above, which basically makes sure that the transaction has all the information it needs. But we don't necessarily need to know that. We're trying to program the transaction. So the asset transfer params, and we'll open up those parentheses and fill in the parameters. So we need a sender. Who is sending the build her token? So the only one that holds it at the moment is the creator address. So we're going to send it from there, and our receiver is going to be our receiver account, which is why I did the underscore account, so it doesn't get confusing. And remember to do the dot address. Okay, so now we're going to send the asset. So we need to know what asset we're sending. And this is why asset ID is very useful, because that's how we are going to identify it. So we're going to set our asset ID of this asset transfer to asset ID, which is what we extracted from the above. Then we're going to do the amount. So how much are we going to send? We can send 10 build her tokens. There's only 1,000 of them. Okay, perfect. So now if we were to run this, there would be an error that comes up. So let's run it and see what that error says. Perfect. So if you can see in the bottom here, it says receive error, must opt in asset 1007. The asset ID is different from the others only because each time we run the script, a new one, a new asset is created, but of course with the same parameters. So we must opt in. Opt-in is a feature of Algorand, which basically gives the user the choice whether or not they want to intake an asset or not. So you don't get spammed with lots of different assets. It is basically an anti-spam feature, and it gives choice, which is very Web3 ethos. So let's do it. Let's opt in. So what we need to do first is fund our receiver account. And we have already done that because we funded our creator account with the dispenser, if you remember. So it's a simple copy and paste, and we just change the receiver. So I'm going to do that just to make sure we're on time. So we do an algorand.send.payment with the pay params. The sender is the dispenser. The receiver is now the receiver account. And the amount is 10 million microalgos, which is 10 algos. And we could see, we know that this works already because we did it for the creator account. So let's keep going. So really quickly, what I'm going to do is, this is the next part that is totally new from the last workshop. So I'm super excited to get into it. This is the atomic transfer segment. So what we'll do is we'll add the opt-in, a payment transaction as well, and an asset transfer transaction. So this is going to be quite cool. This is a layer 1 feature of Algorand, so this means it's way easier to code. Lucky for us. So we do a variable called group underscore transaction or TX, whatever you prefer. We'll just do TX. Okay, so if we do equals to Algorand dot new underscore group and leave that with open parentheses. Now we're going to add the asset opt-in transaction to the group. So the only change in this is basically that we're just letting the code know that we're identifying that we're going to be adding it to into the group. So simply to do that, we just take our group transaction variable that we created from above, and we do a dot, and then we continue as normal. So we're going to do add asset opt-in. Yes, perfect. Add asset opt-in. So this means that we're just, well, it's very easy to read, but we're adding the asset opt-in into the group, into our group transaction. So now if we open up the parameters and just as usual, we're going to add the asset opt-in params, open up our parentheses, and fill in the parameters. So we need a sender. The sender is the receiver's account because the creator already has the token, so they've already opted in, they created it. So the sender for this will be the receiver because this is how they are opting into that asset. So if we put our receiver account dot address, and finally we need to identify the asset that we're opting into. So we're going to have asset ID equal to the asset ID. Perfect. So that's our first transaction within the group, but it's only a group if there's more than one, right? So we're going to just add a payment one because I want to show the flexibility of you can add any type of transaction inside of this. So let's do the exact same process. Group underscore TX dot add underscore payment. Open up the parentheses, and this is very similar to something we did above, which is when we were funding our account. We're going to do our pay params, open this up, and we're going to do our sender, which is equal to a receiver account. I'm going to do dot address after that. Don't forget the dot address. So the sender of the payment is the receiver account, and the receiver is the creator account. So essentially, hypothetically, the receiver is sending one algo, and then they're going to receive token. So we're going to opt in because you need to opt in to get the asset. So none of these will fail. And then we're going to have the receiver account send an algo to the creator account, and then the creator account is going to send 10 build her tokens. Which is kind of cool. So we're going to have our amount here set to, we said we'll do one algo, so that's 1 million micro algo. And finally, the last one, which where I showcase the error, where we're just going to add in that transaction. So we already have it written out, but we'll first add in this section. So group transaction dot add asset transfer. Open up your parentheses, add the asset transfer parameters, and then we can open that up. And we already have it up above here. So I'm going to just take that there. I'm going to delete this because we were doing it down below now. And if we just add this into here. Perfect. And now after this, we just need to execute these transactions. So the way to execute a group transaction is quite easy, is we just do dot execute with the parameters. So now I think it's time to really check, did this actually work? So let's do some print statements. So we could print out the entire information about the receiver account. So I think we'll do that just so everyone can get a grasp of it. So we're going to do Algorand account get underscore information. Open up your parentheses and do receiver account address. Down below this, I am going to do 2 other print statements just to showcase like that you don't always have to print out the entire thing. I'm going to make it a little bit more fancy as well. So we'll have the receiver account asset balance. And what we're going to have here is the Algorand account get underscore information. And in these, we're going to have the receiver account address, as well as outside of the parentheses, you're going to do your boxes, and we're going to have the assets, and we're going to have 0 for the first one, computer start at 0, and finally our amount. So this will be just print out the receiver account asset balance, which is a lot more, to the point. So if I just clear this really quickly, and yeah, we'll give it a shot. Okay, so now if we run this, what should happen is the receiver account should have 10 built here tokens. So let's have a look. Perfect. So if we can see here in our overall, we can see the amount has gone down a bit. Of course, it has to pay its fee, but we also sent 1 algo to the creator account. And what we did as well was we have our total assets opted in, which is 1. So we successfully opted in, of course, because we can see we have a account balance of the built here token for 10. Awesome. So now what I want to show you is I'm going to quickly put this. Now you don't have to do this part. This part is more for when you're doing the challenge later. So I'm just going to copy it so it is easier to read in the terminal and have the creator. And what I'm going to do is, this is the part that will be maybe more challenging to you in the challenge. So I'm going to start you off. So what you do to do a clawback feature is you do another transaction. Anything you do on the blockchain is a transaction if you're appending information. So we're going to do a send.asset transfer because we're dealing with the asset. And in here, we're going to open up our parentheses. We're going to do our asset transfer parameters. And in here, for the callback, what I'm going to do is I'm going to give you some of the parameters, and for the other ones, you have to go find them. So, of course, we need our sender. So the sender will be the creator address. Then we're going to have our asset ID equal to the asset ID. Then there's another one that you'll need to go find. And finally, we have the clawback target. So who is the target of this callback action? And it's going to be the receiver account because we sent them over built here tokens. Perfect. So there are 2 parameters missing here, but this is a good chance to have you go to the Algorand dev portal, and so you can also ask questions. But this is the end of the live coding tutorial. But what I'm going to do now, and you can follow along because we made this code space so that you can do it. But we're going to open up AlgoKit, which is revolutionary for blockchain development. And I'm going to show you exactly why right now. So if I go in here, so we're starting a total new thing. The live coding and what you need for the challenge is finished. But I'm going to show you some smart contracts now and using AlgoKit and how easy it is, all on Python, which Python's only available on Algorand. So if I go in my terminal now, and I'm going to bring this higher, and I write AlgoKit, you can see a list of commands. So for example, we have compile, which compiles the smart contracts and smart signatures that are written in a high level, so like Python, and it breaks it down all the way to TEAL, which is transaction execution approval language. And that is able to speak to the AVM, the Algorand virtual machine. So we don't have to worry about that. AlgoKit does all of that for you. We just need to write in Python. We also have some other things in here like Doctor. That's a really cool one. So if something's not working on AlgoKit, if you do AlgoKit Doctor, it will show you your entire setup, and it might be like, oh, you're missing this. And we're going to use one today, init, which initializes a new project from a template. So let's do it. Let's do our first ever smart contract in Algorand. So we're going to do AlgoKit init, and what you're going to see is basically like, to me, it's like just like a form. So which of these options best describes the project you want to build? Smart contracts, dApp front end, smart contracts, and dApp front end, and then even custom templates. So with the smart contracts and dApp front end, it actually builds out your front end, and it still has smart contracts, and they're already communicating to each other, which is so cool. But what we're going to do for this tutorial is just smart contracts. And the smart contract is going to be in Python. We're going to call it build her, the directory. The name of our smart contract app, we'll just do hello world. And we can do starter or production. We'll just do, it doesn't matter which one you pick when we're just showcasing. So, and we're going to have it that it deploys in Python. After this, we are going to run AlgoKit project bootstrap, which basically makes sure that your environment has everything. So you don't have to worry about it. You can just get straight into coding. Perfect. So then you get a pop-up to go enter the workspace. So I'm just going to go into it. And I'm going to share this tab instead. Now it is just setting up your workspace virtually. Might take a little second. We'll just give it a moment to set up. But while it is setting up the workspace, we can already start to see it come in. We have our root directory, and of course our project build her. So inside build her, we have our smart contracts because we only wanted the smart contract template. When we open up our smart contracts, we can see our hello world, which is the smart contracts that we named. And in here is our contract. So this is essentially just a template that's given to us. You, of course, import the things you need to communicate with the blockchain. But we also, it's very Python. We have our class, we have our function that returns a string. And this is what we're returning, hello plus name. So why don't we just get straight into it? Let's run it. So if we go over to our left-hand side, you can choose to build contracts, deploy contracts, or build and deploy. So let's build and deploy and see what happens. So what is happening is in the terminal, they're starting the local net, which is virtual thanks to CodeSpace. But essentially, and if you do it locally, you'd have Docker, and you run your own little private mini Algorand blockchain. Then what it's doing is it's building out the contract, so the AVM can decipher what is happening, and then it deploys the contract. And here we can see it was successful. We have our application ID, which is 1015, which looks a bit like an asset ID. They're both for the same thing. They identify, the app ID is identifying the smart contract. And here we can see we received hello world. So why don't we do just mess with it a little bit? Before that, you might have just seen that artifacts folder just popped up. Inside here is basically the TEAL, which is what I was explaining earlier, the transaction execution approval language, and that communicates to the AVM. But we don't need to worry about that because that's what AlgoKit just did. It did all of that for us. So if we go to our deploy, we can see obviously the app client deploying, but here our variable name, which is world, let's change it. Let's change it to build her. We're all about build her. Fantastic. And now if we go to our contract, and we'll just change it up a little bit. We'll just do hello. Oh, hello. And then in here, we'll do community. Perfect. So now we changed the smart contract. So what should happen is we should have a new app ID, and the current one is 1015, and of course we want a different output. So let's build and deploy this again. So after it builds it, it will deploy it. Perfect. And there we go. It deployed successfully, and there's a new app ID, and we received hello, build her community. Perfect. So that's how easy it is to get started with smart contracts on Algorand. So you can go in here and start changing it and start deploying smart contracts that you like. You can also do the DApp front end if you wanted to work on some front end side of things. But yeah, before we finish altogether, I want to show you if you want to do this more. Of course, the code space, unless you have premium GitHub, they eventually run out. So how to not have them run out is just to locally set up your environment. So if we could see here at the developer portal, which is going to get updated as well. So quite exciting few months ahead of us. But for now, you can see what we need to set up AlgoKit is Python 3.12 or higher. But you should always update your Python to the newest update, of course. Pipex, Git, Docker, VS Code. For Windows, you can install via the command line, or you can go into the websites themselves and download it. And it's very easy. Once you have everything you need, all you need to do to install AlgoKit is pipex install AlgoKit. And if you're on Mac, it's even easier. All you need is brew. Download Docker if you haven't already. And once you have Docker, you don't need to worry whether you're Windows or anything. You don't need to worry about doing containers. Once you go to like your VS Code, which is just a place where you can write code, all you need to do is run a command algokit localnet start, and it will do all of the container setup for you. So essentially, you just need to download Docker, open it, and then go to VS Code and start algokitting. And finally, I'm going to finish off the end presentation. I have just one or two more slides. So let me see here. Perfect. And I'm back in the bottom right corner. So now it's your turn. Let's get started. You'll get support every step of the way. A bit of the AlgoKit overview, build and deploy template contracts as easy as filling in a form, as you've just seen, and you can just focus on coding your next project. So yeah, get support every step of the way, building on Algorand. We have the dev portal, which I just showed you. We also have the Algo Devs YouTube channel. So you can either watch 15-minute videos and code, or you could watch like I think they have a couple hour long videos to do like a marathon of building a whole marketplace as such. We also have boot camps, and I'll share the QR code in a second, the build her QR code, so be sure to use it. And just before, oh, I've already showed you the developer portal, so that's all good. And it only takes less than 10 minutes to set up your algo kit. So yeah, this is the last slide of the presentation. We do have our beginner Python bootcamps, which I really recommend if you liked what you saw today and you wanted to go a bit further into it. So we have a beginner Python bootcamp on July 29th to August 1st. And we have an intermediate one August 5th to August 8th. And what's involved, and this is the beginner one. So what's involved in the beginner one is it's a project digital marketplace. You'll use Python to create a decentralized application, so smart contract and front end of a digital marketplace. And you'll be able to list your digital projects, assets to sell, define a price, and allow end users to buy them. That's at 10 a.m. EST each day. So the first day, session 1, would be designing and deploying a digital marketplace smart contract with Python. And they do it live coding with you, and the DevRel team are there with you every step of the way. So if you had any questions, session 2 will be testing methods within your Python smart contract. Session 3 will be building a front end for your smart contract using TypeScript. And session 4 is integrating both the smart contract and the front end side. So if you just take, take what you learn from here, and you will already be ahead because you're already getting used to the concepts of what it means to build on a blockchain. So I really recommend if you scan the QR code and register for your bootcamp. But yeah, that is essentially this tutorial finished. Thank you so much for your time. I really hope it was meaningful, because that's the most important thing. And please never hesitate to reach out to me in Telegram if you have any questions or if you're stuck. But yeah, I'll leave the QR on for now. But thank you so much, Builder.
Thank you. This was wonderful as usual. I'm going to drop the link to the Telegram chat again. As a reminder, that's where the office hours will be going. We'll also be sharing the live recording of this, so you can watch this as you need to, and you have 7 days to submit your workshop task. So all of this will be sent over email. And yeah, so I'll just drop that right now in the chat. And thank you all for attending.